Welcome back to the deep dive. We often discuss AI's incredible progress, but one area feels like it's been, well, lagging a bit. I mean, generating truly natural, really long speech, especially when you have multiple people talking, like in a podcast or maybe an entire audiobook, getting that authentic turn taking, the right sort of emotional tone, that natural flow, it's been a real quest, which is exactly why we're diving into VibeVoice today. It's a new model for Microsoft Research, and it sounds like it's designed to really push things forward in synthesizing long-form multi-speaker audio. So our mission here is to unpack the technical report they released. We want to understand its core ideas, how it gets the results it does, and what makes it different. Basically, a shortcut for you to get up to speed on this potentially big development. Okay, so let's first talk about the problem VibeVoice is trying to solve. Text-to-speech, TTS, has gotten amazing for short clips, right? Single speaker voices can sound very convincing now, but scaling that up to long conversations with multiple speakers, that's been a real challenge. You can't just stitch sentences together easily. You lose the natural pauses, the way people actually interrupt or respond. It sounds robotic, not like a real chat.
That's right. And previous research in this specific area, multi-speaker long conversations, has often hit roadblocks. Either the work wasn't open sourced, which kind of slows down progress for everyone, or the systems just struggled with generating really long audio stably. They might break down or lose coherence after a few minutes. So VibeVoice is stepping into that gap, aiming to tackle those length and stability issues head on.
Right. So let's get into VibeVoice's core innovation. The report talks about using next token diffusion. Can you break that down a bit? What does that actually mean in practice?
Okay, so think of it like this. Instead of trying to paint the whole picture at once, VibeVoice works more like building with tiny blocks. It generates these very compact representations of sound, called latent vectors, one after the other, autoregressively. The key is the diffusion part. Each new block or token is generated by refining a prediction based on the sequence so far. It ensures the next sound flows logically from the previous one. It's about building coherence piece by piece. And crucial to making this work efficiently is their new continuous speech tokenizer. This thing is a game changer for compression. Compared to something well-known like Encodec, they're getting 80 times better compression. That's huge. And they achieve this while keeping the audio quality comparable, which is really impressive. To be specific, it's a 3200x compression rate, operating at an incredibly low 7.5 Hz frame rate, just 7.5 snapshots of sound per second.
Wow, 80 times better. 3200x compression, that ultra-low frame rate. Those numbers sound abstract, but what does that efficiency allow VibeVoice to do?
It directly enables the long-form generation. Because the representation is so compact, the model can handle much longer sequences of audio within its memory, its context window. We're talking up to 90 minutes of speech synthesized within a single 64K context window.
90 minutes? That's a whole podcast episode or several chapters of an audiobook, and it can handle multiple speakers.
Yes, up to 4 speakers within that single generation pass. And the goal isn't just length, it's capturing that conversational vibe, the subtle interactions, the flow that makes it sound like people actually talking together.
Okay, so how is it structured? What's the architecture look like under the hood? You mentioned it uses an LLM.
That's right. At its heart, VibeVoice uses a pre-trained large language model. Like Gwen 2.5, they mention versions with 1.5 billion and 7 billion parameters. This LLM acts as the core brain. It's what interprets the input, which includes not just the text script, but also explicit labels saying who should speak when, like speaker 1, speaker 2.
So you feed it the script and speaker turns. How does that work with the voices? Do you need voice samples?
Yes, you provide short voice prompts for each speaker you want to use. The model extracts voice font features from these prompts. Then, it combines these voice features with embeddings from the text script and interleaves them with those speaker role identifiers. It all gets bundled into one single sequence that the LLM then processes to predict the next audio token.
Clever. And you mentioned those specialized tokenizers earlier, the ones doing the heavy compression.
Correct. There are two main ones. First, the acoustic tokenizer. This is based on a type of neural network called a variational autoencoder, or VAE, specifically a variant called ZE. It's got this complex multi-stage structure designed to learn the essential acoustic properties of speech and compress them down to that 7.5 Hz rate, achieving the 3200x downsampling.
And the second one?
The second is the semantic tokenizer. It has a similar structure in terms of processing layers, but focuses more on the content of the speech. It's trained using automatic speech recognition, ASR, as a guiding task. So it learns to create representations that are really good at capturing what is being said, the meaning, not just the sound.
Okay, so you have these two tokenizers creating super compressed acoustic and semantic information fed into the LLM with speaker tags. Then comes the generation part, that token-level diffusion.
Exactly. The LLM looks at all this context, the voices, the script, the speaker turns, the history, and predicts a sort of hidden state. This state then guides a much smaller specialized module called the token-level diffusion head. This diffusion head's job is to predict the detailed VAE features, those acoustic blueprints we talked about earlier.
Mhm.
Finally, the decoder part of the speech tokenizer takes these predicted features and converts them back into the actual audio waveform you hear. It's a step-by-step refinement process.
It sounds quite sophisticated. So the big question, how well does it actually perform? Does it live up to the hype? The report mentions outperforming some big names.
Yes, the results they report are quite strong. In human listening tests, VibeVoice consistently outperforms several strong systems, including both open-source models and proprietary ones like Gemini 2.5 Pro Preview TTS and 11v3 Alpha, at least at the time of the report.
And what were people listening for in those tests?
They used several key metrics. One was overall preference, just which one sounded better or more enjoyable to the listener. Then realism, how natural and human-like it sounded, considering things like intonation, emotion, pauses, and how smoothly the speakers switch turns. And finally, richness, which refers to the expressiveness, the tone, the emotional range, and how well the voice adapted to the context of the conversation.
And VibeVoice did well on those.
Particularly the larger 7B parameter model. It showed significant improvements in perceived quality, delivering, as the report says, richer timbre and more natural intonation compared to the baselines they tested against.
What about objective tests, things computers can measure?
They looked at things like word error rate, WER, which measures how accurately the synthesized speech matches the input text, and speaker similarity, SIM, checking if the generated voices sound like the target speaker prompts. On these objective metrics, the VibeVoice models also performed very well, often better than the comparison systems. Interestingly, even though it's designed for long-form audio, it also performs strongly on standard benchmarks for short single sentences, showing good versatility.
And that ties back to the tokenizer performance you mentioned earlier.
It does. The report highlights that the acoustic tokenizer itself achieved top scores on standard measures like PESQ and UTMS, which evaluate audio reconstruction quality. Getting high scores there, even at that super low 7.5 Hz frame rate, confirms that the core compression technique is really effective at preserving quality, which is fundamental for making the whole long-form generation feasible and sound good.
Okay, so pulling it all together, VibeVoice seems like a really novel approach. It's this combination of ultra-efficient speech tokenizers creating hybrid representations.
Right, both acoustic and semantic.
And feeding that into an LLM using this next token diffusion method. And the result appears to be setting a new standard for generating long, multi-speaker conversations.
That seems to be the takeaway from the report, yes. It represents a significant step forward. Of course, like any new technology, it has limitations that are upfront about. For instance, right now it's primarily trained on and designed for English and Chinese transcripts. Using other languages might lead to, let's say, unpredictable results. It also doesn't handle non-speech sounds, background noise, music, that sort of thing. It's purely focused on the speech itself. And another key point, it doesn't currently model or generate overlapping speech where speakers talk over each other, which happens a lot in natural conversation.
That's an important limitation to note. And they also mentioned potential risks, right?
They do. And it's crucial to acknowledge this. The ability to create highly realistic synthetic speech, especially replicating specific voices, naturally brings risks. Misuse for creating deepfakes, impersonating people for scams or fraud, spreading disinformation. These are serious concerns with powerful synthesis tech like this.
Which leads perfectly into the final thought we wanted to leave listeners with, taken directly from their own report. They state, users must ensure transcripts are reliable, check content accuracy, and avoid using generated content in misleading ways. It really puts the onus on us, the users and developers, doesn't it? As these tools become more powerful, our responsibility in how we use them and how critically we engage with the media we consume becomes even more important. They stress it's for research and development and should be used responsibly. Something definitely worth thinking about.